top of the hill to the next top of the hill. But you can go from any point to the next repeating element, so 9. Good? Now you gotta get that right in order to get the rest of these. Number 4, right? Because remember, every 9 you repeat. So what did you get for h of 13? 2. Because h of 13 will be the same as h of 4, because 13 is, or 13 minus 9 is 4, and every 9 you repeat. All right, what'd you get for B? Negative 2, because h of negative 12 is the same as h of negative 3. And what about C? 3, because h of 82 will be the same as h of 1, because we can back up 9 periods. Perfect, beautiful. All right, now we got a little sine curve here in number 7. 2 complete cycles are shown. What is the period of this guy? Pi. Period's pi. So if the period is pi, then what are you going to do with 3 pi? Would 3 pi be the same as 2 pi? Would that be the same as 1 pi? And 1 pi has a value of negative 1. What about 5 pi over 4? Same as 1 pi over 4? What? So, for B, I don't think so. Where's 1 pi over 4? Where does pi over 4 be between 0 and 1/2? Would that be right here? So what's your y value right here? 1. Yeah, it's 1, not negative 3, it's 1. So B should be 1, right? Would you agree with that? What about negative 5 pi over 2? What'd you get for that one? Negative 1. Every pi, it repeats. So negative 5 pi over 2 would be the same as negative 3 pi over 2, or negative 1 pi over 2. So negative 1. Okay, number 10. You may not have gotten this far. When he writes this, what does this automatically tell you? What does that tell you? Period 10. If you have something and you add 10, you end up right back where you were originally. This says the period is 10. Okay? So, what are you going to do? If you don't have it done already, think about it now. What are you going to do with G of 27? The period is 10. So what are you going to do? See, it says subtract 20. Can we do that? Yep, because that's 2 periods. So that would give us G of 7, which we know G of 7 is 5. What about G of negative 7? That one. Well, it says add 10, and that gives us G of 3, which is negative 2. Ooh, what about G of 10? Start with G of 10. Alright, so start right here. What's that? G of 10. Same as 0. And that is 4. So this is 4. So now we're going to find G of 4. And in our chart, no. So what would 4 be the same as? Negative 6. Remember, every 10 you repeat. And G of negative 6 is 1. I always like to write these backwards of how he does. My period's 10, right? So So isn't this saying I'm gonna take -3 and add multiples of 10? And what will that do? Adding multiples of 10 does nothing. So isn't this the same as doing -3? Do I have that one? Shoot, no. So let's see, I'll have to maybe add 10. To get 7, so that one is, how do we feel about that? Okay. All right, back side of that, I want to do number 11. This is the last one we're going to have time to do, but I want to do another one like this because, as I told you yesterday, this was actually on the exam. With more pieces than this, but it was like this. All right, so read through the problem, and we're going to approach it the way we did yesterday. We're just going to make a list of some points. So while I'm drawing it, you go ahead and read through the problem and see if you can start making up a list of points. We're not plotting them yet. We're not plotting them or anything. We're just looking at the given situation and seeing if we can come up with some points. Would you agree that the first point is 0, 0? And they tell us that times 0, the distance is 0. This is time and this is distance from the wall. So when is the next time I'm going to get 0? This is periodic, it's going to repeat. When is the next time I'm going to get 0? 8? How do I know it's 8? It takes 8 seconds to get around the track. Okay, now what does that mean? That means halfway in between, where's the car? On the other side of the circle? So what is that distance from the wall? 40? Why is that 40? So 20 on each side, the radius is 20. Okay, so this is when the car, here's the wall, here's the track. These two are when the car is here. That one is when the car is here. So when is the car here? Do I know which way the car is going? Is it going this way? Okay, so when is he here? 2 seconds. And what is this distance from the wall at 2 seconds? And then when is he over here? This would be 6 seconds. Is he up here? And what's that? Also 20? Do those points make sense to everybody?
Why? At 2 seconds, why is he 20? Because it's just.
Wouldn't that be the same as radius? Got it now. And we could keep going around the track, but that's certainly enough. So now we gotta figure out where these points are gonna go, because we have to actually label them now. All right, so what do you think? Now, we can have other, we don't have to use these points. We can make more if we need them, but we need to start getting something on here. So, what do you think? But what's the lowest y value I have? 0. So this would be the lowest, right here. So I'm going to call that one 0, 0. Or maybe it's better, I'll call this one 0, 0. Can I do that? All right, if this one up here would be what? 440. And what would this one be right here? 80. What would this one be then? That one would have to be 620. What would this one be? Can you figure that out? It's not one of our listed ones, but can you figure it out? 1020. Does that make sense to everybody? 1020. And then what would our last one have to be? 1240. Now remember, these things have more than one answer. So what we need to do is agree or disagree if this is a possible set of coordinates for this picture. Would you agree with that? But there are others, certainly, but this would be one set. I do like to avoid negatives here, because remember, this is our time coordinate, so I'd rather not go back too far and have negative x's or negative t's. So no, that was okay. All right, let's answer the rest of the questions. On, let's see, T1 is J, and T2 is K. So this time we are looking at this part of the graph right here. So what's true about our function on that part of the graph? What would you say? Positive and increasing. This is 0, right? Here we're 0. Isn't this above this is the x-axis? Aren't we above it? Here? Yeah, we're good. So A is the correct answer. How is the rate of change changing over that interval? Is the rate of change positive or negative? Positive, because the curve is going up. And then how is it changing? Is it increasing or decreasing? Increasing because we're concave. You good with that? Okay, let's put that sheet away. Someday we'll probably come back to it, maybe or maybe not. I don't know. Put that away. We need to get moving on unit 1. But when the bell rang or when we were ended yesterday, we were at the back of page 3 in our notes. I numbered it this time for page 3. We were on the back of page 3 when we were talking about the tides, the height of the water, talking about that. We determined that the period of this thing is 12 hours. You can tell that from the picture. Low tide to low tide is 12 hours, or high tide to high tide. When, or what do you expect to be the water level at T equals 33? At T equals 33, remember the period is 12. So where would I look? At 9? And the water level at 9 is 4 feet? Everybody okay? Why would we use 9? All right. And when is the water level changing the fastest? And how do you know? This is a great review question. Who remembers? When is the rate of change changing the fastest? Point of inflection. There's our hero. That is where the rate of change is changing the fastest. And how do I identify a point of inflection? It's where I change from being concave up to being concave down, right, where concavity changes. So it looks like at 3 hours and at All right, 3.2, here we go, a few minutes, and we're gonna go to lunch. Let's start 3.2 real quick. So in order to standardize our conversation, our angles are always gonna be measured in standard position. Standard position means we're starting on the positive x-axis and we're rotating from there. So this would be an angle in standard position. Vertex at the origin, initial side, starting side, is called the initial side, or the initial ray, and this is called the terminal ray, or the terminal side. So we're rotating this way. If I rotate up and round, my angle is positive. If I rotate down and around, my angle is negative. They all start in the same place. They just either go up or go down. When I look at one of these guys, draw an angle in standard position, so there's some angle, call it theta. If I drop a perpendicular straight down to form a little right triangle, would you agree that this side of the triangle is x and this side of the triangle is y? So if this is the point, I'll just make something up. If this is the point 1, 2, then this would be 1 and this would be 2, right? And this guy right here, we call the hypotenuse, but he can also be considered the radius of our circle. And the work we did with the learning, I let the radius be 1, and then the sine and the cosine were x and y. Well, in a different size circle, sine is defined as y over r. You might remember sine being defined as opposite over hypotenuse, SOHCAHTOA. It's the same thing, same exact thing. And now it makes sense why sine is y in the unit circle, because if you're in a unit circle, r is 1. Cosine is defined as, what do you think? Cosine is defined as x over r. And tangent is defined as y over x. Same as it is in the unit circle. Opposite over adjacent. Now, can sine, cosine, and tangent be negative? Yes, we know that. When are they, what determines when they're negative or positive? Think of your unit circle. Why are some of them negative? The quadrant you're in? Would anything be negative in this guy right here? No, because I'm sitting in quadrant 1. But as soon as I draw that triangle over here, my x's or my cosine will be negative, right? And my tangent. All right. So, we're going to go to lunch. And we're going to be back. Hold up. Let me tell you when to be back. Things change by the minute around here. We're back at 1:05. 1:05.